Hello, this is Mr. Miller, and in this video we're going to do 3 examples of writing equations for polynomial functions. It's very similar to what we did with quadratic functions a little bit ago. All right, here we go. So first we have this cubic polynomial, third degree, and we want to write an equation for it. And the information we're going to use are the roots of the function and the given point that's marked there. So I see that there's a root right here at x equals 1, right there. And there's also a root here at x equals 5. The one at x equals 1 has multiplicity 1. I know that because it crosses. And I know it's multiplicity 1 instead of 3 and 5 because this is only a cubic polynomial. So this one has multiplicity 2. And together, that multiplicity 1 and that multiplicity 2 add up to 3, which is the degree of the polynomial. All right, so if I know those roots, that means that we have factors x minus 1 and x minus 5. And since the root 5 has multiplicity 2, we're going to make this squared. So in addition to this, we could also have a number multiplying out front, and we represent that with a. So the basic pattern is y equals a, x minus 1 times x minus 5 squared. Okay, and that's what this point is for, using it to find the value of a. So when we put in 2 and 4.5, we get 4.5 equals a times 2 minus 1 times 2 minus 5 squared. All right, this looks like a mess, but this part is just a number. We can put that in our calculator. In fact, we get 9. So we get 4.5 equals a times 9. All right, and if I divide by 9, we can figure out the value of a. So we get 4.5 divided by 9 is a, which means a is 0.5 if you divide that. And actually, I prefer a fraction, so we're going to take it as 1/2. All right, so our final equation is, in factored form, is y equals 1/2 x minus 1 times x minus 5 squared. If you type that in the decimals yourself, you're going to see this beautiful graph. All right, standard form is what we get when we multiply all this out. And we've been using Wolfram Alpha, and to be honest, it's not that pretty. I'll tell you what Wolfram Alpha gives you. It gives you 1/2 x to the third minus 11 halves x squared plus 35 halves x minus 25 halves. All right, that is standard form. All right, so in this case, factor form is kind of nicer, right? A little bit shorter. But anyway, there's both forms. All right, next one. So this is a higher degree one. This is a 4th degree polynomial. And I see that we have a root here at -2. And we have a root at 0. And we also have a root here at 4. Okay, so those tell me what the factors are going to be. So we're going to start with y equals a. All right, this one is a double root. The graph turns around and touches it and goes back up. So I know that this is going to be x plus 2 squared. All right, it crosses through 0. That's a root multiplicity 1. So you could put x minus 0 for that, but that's just x. And then it crosses again at 4. So we have x minus 4. All right, so this has multiplicity 2 and exponent 2. These have exponent 1. And I'm going to rewrite that like this. I like the x out front. So x times x plus 2 squared times x minus 4. Okay. So again, we have to use a point to figure out a. So at this point, this time we have this point, 2, -8. So I'm going to substitute -8 in for y and 2 in for x. So get a times 2 times 2 plus 2 squared times 2 minus 4. And again, all of this is just one number. We can put this in our calculator and see what that is. And I believe we get negative 64. So we get negative 8 equals a times negative 64. So we get a equals negative 8 over negative 64. We want to reduce that. We don't want the decimal, so that's equal to 1/8. All right, got to put that back into the equation here for a, and we get y equals 1/8 times x plus 2 squared times x minus 4. Okay, we pop that in the Wolfram Alpha. We get a little bit of a mess, but here it goes. That's why Wolfram Alpha is so great. So we get y equals 1/8 x to the 4th minus 3/2 x squared minus 2x. Okay, beautiful. One last example. I want to do this example because this function has two complex roots. So these are two of the three roots. It's a cubic function. The other root is found right here at negative 3, and it has multiplicity 1. So we're going to do the same thing. It's going to look a little messier, though, because of the complex roots. So we have y equals a times x plus 3. That's due to that root. Times x minus parentheses 2 plus I and x minus parentheses 2 minus I. Wow, okay. Same thing. Going to put in 0, 5. So we're going to put 5 in for y and 0 in for x. So we get a times 0 plus 3 times 0 minus 2 plus I times 0 minus 2 minus I. And as I said each time, this is all just a number. If we carefully enter our calculator, getting all the parentheses in the right place, you actually get 15. All right, so it doesn't look like 15, but it is. So we get 5 equals a times 15. So we get a is 5 divided by 15, which is 1/3. So this time, factor form's a little bit of a mess. So we have y equals 1/3. We have x plus 3. And we have x minus 2 plus I. And x minus 2 minus I, like this. And if we really wanted to, we could have Wolfram Alpha just multiply these two factors and come up with something nicer. But that's okay. We'll leave it like that. And the standard form is y equals 1/3 x to the 3rd minus 1/3 x squared minus 7/3 x plus 5. All right, so a little bit complicated, but what I see is that when we multiply all this out, no more complex numbers, all right? So this is a polynomial for that function. All right, this is amazing, and this is kind of near the end of our study of polynomial functions. So work hard, you can get this, and then we'll move on to something else. Take care.